Hi folks and welcome back. We're going to be doing 6.5 operations with radical expressions, and this is part 2. So if you've not watched part 1 of 6.5, I would go back and review part 1, which is simplification, multiplication, addition, and subtraction. This part now is going to be division of radicals with nth roots. All right, before we're starting out here, I would encourage you to draw a box. So let's see, I want to leave enough room for my permanent marker here, and then for titles. Just going to draw a box. I like this box. Maybe I can actually extend it a little bit here. It's going to drive me crazy that it's not straight 100%, but you're going to make, let's see, these are rows. You're going to make 2 rows and give yourself enough room for 3 columns. This first column can be a little bit skinnier than the next 2. All right, we are going to work on rationalizing. It's probably actually not a real word except in math. The denominator. Now, we've done this many times before. You learned this originally in geometry, and we've definitely worked with it this year so far. But we have been rationalizing what we call square roots, and that's what we're used to. Well, in this entire section, we're working with nth roots. So how do we rationalize something that does not have a square root, what we're used to? I'd like you to title these columns, if denominator is, and then you're going to have another column, just gonna do that, multiply numerator, I'm gonna say numerator and denominator by, and then examples. So n equals, I'm just going to say n equals numerator, d equals denominator. I was not going to have room to write that up there. So that kind of explains what those two variables mean. Okay, so we're going to do a first one. If the denominator is 1 divided by root x. This is what we are used to. We're used to having a root x in the bottom. Well, if the denominator is a root x, you're going to multiply the numerator and denominator by root x over root x. We're used to this. This is something that is called rationalizing. We've done this many, many times before. Our example here, if we have 2 divided by root 3, we cannot leave rationals or rational expressions right here. Sorry, radical expressions. We cannot leave a radical in the denominator. So it's a big no-no. We're going to multiply that by root x over root x or root 3 over root 3. That is going to get us to 2 root 3 divided by 3. And that is our final answer. Let's go down to our second box here. We're going to now have 1 over nth root of b to the x. So this is our new one now. 1 over the nth root of b to the x. Well, if the denominator is the nth root of b to the x, you're going to multiply the numerator and denominator by the nth root of b to the n minus x. Extend that radical right there. Over the nth root of b to the n minus x. Again, you're just multiplying by 1. You're not changing the equation at all. Both of these divided by itself is going to be 1. So you can multiply by anything, big or small, as long as it is the same expression over itself. So the reason why you need to do this is so that it cancels out with the nth root. I'll give you an example right here. If we have 5 over the third root of 2. Well, we cannot have an nth root in our denominator, so we need to multiply this by third root of. Now, this exponent is 1. There's an invisible 1 right there. So, 2 to the, we have to do nth root, 3 minus x, which is 1. So 3 minus 1 is 2. 2 squared over the third root of 2 squared. And this is all going to equal now, and I'm actually going to put it outside of the box so I'm not squishing it right here. But we have 5 times the third root of 2 squared is 4 divided by 2. All right. And that, folks, is going to be our answer. This was up here, and this was down here. All right, so let's look at a couple more examples now that we have this box done for us, kind of our rules to look back at. I'm going to give 3 separate examples. So we have example 1 right here, example 1. Let's go root 16 over 25. Now, the radicand right here can be actually split apart. So this is the same as saying root 16 over root 25. Well, both of these exist. So root 16 is 4, root 25 is 5, and that is our most simplified answer right there. This is something we've done before, but I kind of wanted to get your brain working and, remembering how this all works. Let's do another one. Let's do example 2. So example 2, if we have the square root of 49 divided by 5, we're going to break this up. Root 49 divided by root 5. Well, root 49 exists. That's 7. But root 5, cannot leave that in the denominator. You must rationalize it. So I'm going to multiply this by root 5 over root 5. And our final answer is 7 root 5 divided by 5. Okay, let's go to our new one then. We're going to review those rules right there to rationalize an nth root, the nth root of b to the n minus x. So let's look at, we're going to do example 3. We'll do the cubed root of 24 divided by 216. Now, looking at 24 divided by 216, those are some big numbers right there. I'm going to grab my calculator and see if those themselves actually simplify. So we're going to go 24 divided by 216. Lovely decimal. That's, as I call it, math bracket. And that is 1/9. So I'm going to rewrite this as the cubed root of 1 over 9. It's going to make my life a little bit simpler. We're going to do the cubed root of 1 divided by the cubed root of 9. Well, the cubed root of 1 is 1. Cubed root of 9? Not so much. So, remember, this has an exponent of 1. We're going to look back at our rules up there. And we're going to rationalize by multiplying this by the cubed root of, and we have to look at this. Well, we have an n and an exponent of x. So 3 minus 1 is 2. So we're going to do 9 squared here over the cubed root of 9 squared. And this simplifies to the cubed root of 81, which is 9 squared, over 9. We are not quite done yet. We have a little bit more to go because the cubed root of 81, you can break this apart. Cubed root of 81 can actually be written out. Cubed root of, well, 3 to the third times 3. And this is all over 9. And I'm going to be losing a little bit of room here, so we're going to go up here. Hopefully you can get that. We now have cubed root of, we left off with 3 to the third times 3 over 9. Well, 3 divided by 3 is 1. So we have 3 on the outside. Cubed root of 3 left over. And this is all divided by 9. Our last simplification step is 3 divided by 9 can simplify because 3 divided by 3 is 1. So this is left with 3 root 3, and 9 divided by 3 is 3. And that is our final answer. All right, folks, there we go. That is division. Again, I would encourage you to look at the other study guides I have given you. If you are in my class, if you are just watching this YouTube video, I would encourage you to work with this and get this into your head with examples. The only way you will get better at this is by doing examples and working with the problems. Please reach out if you have any questions. Thank you.